we're going to graph two equations and tell where they hit each other. In order to do this, you have to know what you're graphing. So beforehand, you have to figure out what it is that you're going to be graphing. So looking at these two in your experience, you should be able to tell right away what they are. The first one is a parabola. And the second one up there is a line. So we're going to be graphing a parabola and a line and stating the solutions if there are any. If there aren't any, it's a guppy. Okay? We already know how to do all this. So the parabola has a vertex of 2, 1. And the A value is 1. So I know it's going up, and it's going to be a standard 1357. So from 2, 1, we go up 1, up 3, and I've got just enough room to go up 5. You want to be as accurate as you can when you draw these because it's important that when you graph two of them together, you get an accurate intersection point. So draw your parabola kind of accurately. Anytime these things intersect, and you're supposed to state the solution, they're going to intersect at an integer point. So you're not going to have to guess 3.5, 2 7/8 or whatever as the solution. It's going to be an integer. So there's my parabola. A line, which you've been graphing for about 4 years, y equals negative 4x plus 5, has a y-intercept of 5. Well, there's one of my solutions right there. And it has a slope of negative 4. So I'm going to go down 4, right 1 a few times, and up 4, left 1. And this one's a little bit difficult to see, but it actually only hits that parabola in that one spot, because the line would tail off, and the red only hits the blue in that one spot. So the solution is 0, 5. So that's kind of a basic example of what we're going to be doing today. Now we're going to do y equals 6x, and then we're going to graph the hyperbola, x squared over 4 minus y squared over 16 equals 1. So we have a line and a hyperbola. Okay. The hyperbola is horizontal because the x is first. All things that we've talked about that maybe you don't know off the top of your head right now, but if you look at your cat to make a pair of kitten britches, you will see that the difference between a horizontal equation and a vertical equation is which letter is first. So the x is first, so this is a horizontal hyperbola. The center is 0, 0. Okay, well let's graph the line first. Y equals 6x plus 0, y-intercept 0, slope of 6. There's my line. Doesn't have to be dotted, it's just dotted to be dotted. You can make it solid. So now my hyperbola, my center is 0, 0. Right there. Remember CVA, that's how you graph. Center, vertices, asymptotes. And you got to freehand your parabola a couple days ago. That's what we're doing right now. The vertices for horizontal hyperbola, h plus or minus a, comma k. That's 2 and negative 2. Because a squared is the first denominator. And we talked about yesterday how the vertices are a away from the center. And so it's going to be 2 and negative 2 away. So there's where your parabolas are going to originate from. I can see right now this is a guppy. But I'm going to continue to graph Slopes of the asymptotes is 2. So from my center, I'm going to take slopes of plus and minus 2, and those are yellow. Up 2 over 1, up 2 over 1, up 2 over 1. Draw my parabolas to snuggle up to my yellow asymptotes. And the asymptotes, I'm glad that you can barely see them because they're really not there. They're just a guide. Like if you graph that on a graphing calculator, the asymptotes aren't there. We just use it as training wheels for our graphing. So where does the blue hit the orange? It doesn't, so there is no solution. So there is no xy coordinate in the universe that works in both of those equations. Back to our theme of the whole year, find the number that works. There is no coordinate that works in both of these. Now, so this one has inequality signs. So we're going to graph it, and we're going to do it the same way we've always done. We're going to test points, see where we're shading, just like we've always done. This looks like 2 circles to me. And so the first circle has a radius of 5 from a center of 0, 0. Is the circle solid or dotted? Solid. You can test the center, 0, 0, because the center is not on the circle. If the 0, 0 was actually touching the circle, you couldn't test it. You'd have to test something else. If we test 0, 0, we get 0 is greater than or equal to 25. Is 0 greater than or equal to 25? No. So the center is not shadable. It's false. So for this red circle, we're actually shading away from the center. The second circle, also centered at 0, 0, has a radius of 10. Oh, another big one. Good night. All right. Also solid. 2 circles that have the same center. Anybody remember what those are called, Maddie? No. Anybody else? Concentric. Very good. We would... last year I was playing hangman with that word. Trying to get people to remember it. So anyway, 0 is less than or equal to 100. That is true. So we're shading inside the blue circle. And so the shade is right there.